Hi, welcome back to school. Good morning. Our objective for today is to be able to solve for the volume of the pyramids and cones by using the formula and showing step by step work. Let's take a look with this picture. This is one of the wonders of the world, and this is outside our country. This is in Egypt, and this is what we call the Pyramid of Egypt. There's a lot of pyramids in Egypt. Amazing structure, very awesome. That's why it's one of the wonders of the world. How about here in United States? In our country, we also have like this. And that's a very huge building that will be found in our neighboring state. That's in Nevada, in the city of Las Vegas. So there's an array of hotels there in the Las Vegas Strip, and one of them is the Luxor Hotel and Casino. So there's a lot of hotel rooms inside. We have some dining, some entertainment. We also have the casino and some shopping um, stalls. So if we wanted to measure the capacity of this building, of this pyramid, we need to do the volume of the pyramids. But first, let's understand about the pyramids on their volume. The volume of a pyramid is related to the volume of a prism with the same base and height. The relationship can be verified by dividing a cube into three congruent square pyramids, as been shown on the diagram below. Now, let's focus on the diagram at the bottom. This one? Okay, let's focus for this. That's a cube. All right. The cube has actually three pyramids, specifically three square pyramids. One of them is showing up here. The base is the yellow. Okay. And then the second square pyramid is the base is the purple. And then the third pyramid is the base is green. These three square pyramids are coming out from the cube. If we put them together, it's making a cube. So this is the reason the volume formula in solving for square pyramids or with even other pyramids would involve a fraction. So we can see here one third because there's three congruent pyramids in a cube. Now let's have specific example here. So on this example, the shape of the base of the pyramid is a square. So we label it a square pyramid. And that square at the bottom has a side of 9. So there's four sides, equal sides, 9 centimeters each. The height of the pyramid is 14 centimeters. Now let's use the formula in solving for the volume of pyramids. V for volume is equal to one third capital B, which is the area of the base of the pyramid, and that's the square for this example. H is the height of the pyramid. Now let's set up a specific formula. We will replace that capital B. So the shape of the base is a square. So the area of the square is S squared. And because of that, the volume will be equal to one third times S squared times height. Let's plug in the numbers. So S is 9, so it will be the S squared will be 9 squared, and H is 14. Use the calculator. One third times 9 squared is equal 14. Times 14 rather. The other way how to solve that one in your calculator, 9 squared or 9 times 9 times 14 and then divide it by 3. And you'll be getting 378 cubic centimeters. It's very important that the unit should have the exponent of 3. It should be cubic. If it's a mile, then it should be cubic miles. If it's feet, it's cubic feet. It should be specific. All right. Now, what if we have a pyramid that the shape of the base is a rectangle? Then we call that a rectangular pyramid. So we will make a specific formula for that. For the volume of pyramid's formula is 1/3 BH. Therefore, the base of a rectangular pyramid is a rectangle. Area of a rectangle is length times width. So we will replace that one. And our final formula would be V for volume is equal to 1/3 times length times width of the base of the pyramid, which is a rectangle, times the height of the pyramid. Another pyramid is triangular. It's called triangular because the base is a triangle. So let's expand our original formula. So the B will be the base area of the pyramid, which is a triangle. How to get the area of a triangle? So we have the base, which is the leg of the triangle, times the height of the triangle. So base times height, or BH, divided by 2, or 1/2 BH. So the final equation or formula for the volume of a triangular pyramid is V for volume is equal to 1/3 times BH divided by 2, and then after that times height of the pyramid. So that's for the pyramids class. Let's talk about this. It seems I'm feeling hungry right now. I love sweets. So this is a cone of an ice cream. So the cone is here at the bottom. If we tried to fill this in with a lot of ice cream, then we can tell how much is capacity. And we need the volume of a cone formula. So we will be using this formula. V is equal to 1/3 BH. And we have to be specific since the mouth or the base of a cone is circular or circle. Then we have to use the area of a circle, which is pi r square. So the formula would be V is equal to 1/3 pi r square times h, or height of a cone. Now let's apply a specific example. So with this example, we don't have the height. So the height is from the tip of the cone going down to the bottom or center of the base. We don't have that. So that's one of the leg in a right triangle. And then the radius is another leg. And this one here, going to the side, sideways, is the hypotenuse. It is common that people would think this 34 is the height. It is not. So if the height or one of the legs is missing in a right triangle, we need the Pythagorean theorem. And we all know that's a squared plus b squared is equal to c squared. Let's plug in the numbers. So a is 16. The a squared will be 16 squared. We don't have yet the b, so we'll keep the b squared. The c is 34, so 34 squared. So 16 squared, 16 times 16 is 256. 34 squared, or 34 times 34, is 1,156. We need the b. So we have to remove 256 from both sides by subtracting it. So what we're getting is b squared is equal to 900. How to get b? How to make b squared a b? We have to apply a square root. And we have to do that in both sides. So the square root of b squared is b. Use the calculator. The square root of 900 is 30. We will include the unit. It's centimeters. So b, or the missing height, is 30 centimeters. And because of that, We can apply it now to the volume formula of a cone. So V is equal to 1/3 BH. B is the area of the base of the cone, which is circular, and H is the height of the cone. So which is the leg, one of the legs of that triangle, the one that we have solved. So let's plug in the specific formula. So V is equal to 1/3 pi r square H. Let's use pi as like 3.14, though there's the longer digits. But let's just say we'll use 3.14, okay? So r, our radius, one of the legs is 16, so 16 square, and then height is 30, the one that we have solved recently. Let's plug it into the calculator. So you can put this in the Desmos calculator, like 1/3 times 3.14 times 16 squared times 30. Or you can also do like this, 3.14 times 16 times 16 times 30. And after that, divide them by 3. And our answer here, the volume is about. Why it's about? Because we use an estimated value of a pi. So that's why we have this symbol, approximate, or is about 8,038.4. And the unit of measurement is in cubic centimeters. Why is cubic centimeters? We're using all centimeters in that dimension, so we have to use centimeters. Why it's cubic? Because when we measure volume, the answer should be in cubic units. All right, thank you. And if you need to replay this, you may do so to learn and relearn. So we have the group report posted, and we also have the exit ticket posted. Thank you and have a great day.